Welcome back. It is week 10 by my count. Depending on who you ask, we either have 14 or 15-week semesters, so that's pretty far through the way. Some of you are probably starting to think about course registration. Does that sound correct? If any of you would like a advisor for the CS major, and I can probably do the data science major if you need that, email me right now. You have your computer open, just send the email right now, and I'll get that taken care of soon. I'm starting to begin to fuel the advising system, and surely there will be no disasters this semester, as there have been no disasters in the past. An example of a disaster is in 2 or 3 years, you show up in my office and you're like, can I graduate on time? And it's like, ooh, I wish you talked to me sooner. That's the example of a disaster. There's no immediate disasters. But if you're interested in the major, the sooner you talk to me or another in-major advisor, the easier things will be on you. You'll have more selection of which classes you want to take, basically, and have more choices about things like study abroad. So that's basically the stakes. They're not that high. That said, even if you are a first year in your first semester, it makes sense that we would talk immediately. And I will continue to encourage you to reach out to myself or someone else. If you don't like me, the next best suspect is probably Jed Rembold, who runs the sections. And then the other people around this term are Fred, who's downstairs and teaches the next class, Rachel, who's across the call. She teaches in the master's program. Who else do we have? Lucas is also downstairs. Lucas is teaching our software classes this term. And I'm happy to introduce you to any of them if you would like. If you're more interested in data science, of course, can introduce you to Professor Kadata-Smalley, Professor Gore, or Professor Eibser, who are all downstairs as well. Am I missing someone? Oh, Professor Zek is first year. I don't know if Zek is taking advices yet. Today we're learning about this word. And I was going to pronounce it correctly on the first try, then I forgot which one you say. So, this is pronounced tuple, according to Wikipedia. I have no reason not to believe them. What is the usefulness of saying tuple? Well, if you say tuple, these things can be of different lengths, and when I was learning about them, we referred to things like 2 tuples and 3 tuples and 5 tuples. If you say tuple instead of tuple every time, then you can use tuple to refer to 2 things, threeple to refer to 3 things, and fourple. So it can be nice to have tuples and tuples and use them to refer to different things. So a tuple is a tuple of length 2, perhaps. So I'm going to try and say tuple all day today. Am I going to succeed? No, of course not. And is that even particularly helpful? No, because the reason I remember how to say tuple is that it rhymes with couple, which is also 2 things, right? So we're going to do our best. Check in on announcements. Problem set 5 is due tonight. I don't know when I'll start taking a look at them. In the olden days, I always liked to grade them as they were coming in, and then like the last couple would come in at midnight and I'd be done the same time they were due. That's like a lot of work to keep track of what's in and what's not. So I'll probably look at them sometime tomorrow. I do want to look at those quickly for you because of Project 3. By my count, Project 3 is now posted. Have you all been able to see it? I don't not trust you. I don't trust me. There we go. So I'm going to click this button. Okay. That seems legit. Does that seem legit? I'm going to accept the assignment. I'm going to open it. Again, I trust you. It's just I don't trust me, right? Okay. How do we always get this code? We always download the zip, right? We're zip downloaders. They call me the downloader of zips. Is this open? What do I do here? Open with VS Code? Okay. And then if I just go here and I run image shop, it doesn't work because I have the special version of things. Where is it? There it was. Don't look at this. I'm embarrassed. Okay, never mind. Okay, so now it's going to work. Very good. Okay, and so you can all see something like this, probably. Can I get some like thumbs up or something? Maybe some signs of life. Maybe a woohoo! No woohoos. Okay, that's fine. And then when I click this button, I'm able to load an image. My, of course, favorite image is zebras. Yeah, very good. Okay. And then I can vertical flip zebras. Okay, and that's what you're working on. Does anyone have any questions about Image Shop so far? I'm assuming you haven't started yet. Okay, come with questions on Wednesday. Don't get stuck on this. Get to the last one as fast as possible so you have time on it. So just, these early ones, they're just like an amuse-bouche, right? Just like a little special something before you get into the main course, right? Okay, so that's Image Shop. Am I going to talk about Image Shop at all today? No, of course not. That would be ridiculous. Okay, so what are we doing today? We're talking about tuples. Woo, that's hard. Okay, we're going to unpack. We're going to pack, which is multiple assignment. We're going to enumerate, and we're going to zip. And have any of you stumbled across enumerate yet? Okay. It was very popular last year, but last year liked just like copy pasting the assignment instructions into ChatGPT a little more than you all do. So ChatGPT really likes enumerate because it's bad at programming. So all right, let's introduce the humble tuple. Fun fact, I'm teaching tuples in my 200 level class today too. We just happened to be doing the same thing for this week. So that is funny how that works. So I'm going to spend all day being really stressed out about how to say this word. Okay, so sometimes you have more than one thing. What do I mean by thing? Well, intuitively, I sort of mean value, right? So a grect, for example, has x and y coordinates and x and y side lengths, right? So maybe we can describe a grect with 4 values. A rectangle that isn't in a particular location has a height and width. A location in the coordinate plane has perhaps an x and y location. But there's other examples. So here at Willamette, I've been thinking about advising. That's why I asked you all about it. Generally speaking, we represent courses as the tuple of a prefix and an integer, or I guess a natural number. None of them are 0 and none of them are negative, right? So CS 151 is, I think, something we have like kind of an intuitive grasp of, but we can think of that, or a computer would probably interpret that as a tuple, right? First, middle, last name is pretty common. That would be a tuple of 3 strings. But we can put things in tuples other than that stuff, right? I can put another tuple in a tuple the same way I put lists inside lists. I can put functions inside of tuples. So, who put favorite CS1 instructor on here? Remember, if there's a quiz on this, your favorite CS1 instructor is your section leader. Do not put my name down on there, okay? I don't exist. I'm a fictional character. Okay. So, I'm coughing already. Oh no. Okay. Here's something unhinged that you should never do. Oh, I won't show it in the terminal. We probably don't like the terminal, right? Is terminal bad? Can I get some boos for terminal? Terminal's okay. Can I get some loud cheers for VS Code, which you're required to like? Yeah, we all love VS Code, right? We also have free will. Can I get some like mumbles for free will? Like, nope, okay, we don't have free will. That's okay. So, here's something that I did in Python once by accident, and I was very, very sad it works. You can set x equal to, is that too big? You can set x equal to 1, 2. Why is this allowed? I have no idea, right? Okay, so for some reason that's allowed. And of course this immediately suggests to me I should like figure out what x looks like. And what's that? Springing from nowhere, like a bolt of lightning from the cloudless sky. There are 2 parentheses around my 1, 2. that I just wrote in 1, 2. From whence doth those parentheses hail? That's what you got to ask. From whence? Okay. From, that would be hence, right? Whence is time. Does any? Sorry.
Hence is time.
Yeah, that seems fine. From where? Yeah. Okay. Never mind. Don't listen to me. Okay. We think hence is time. We think. Huh. All right. Well, we'll take that. Okay. So, from whence doth those parentheses hail? Right. That's what you were all thinking, right? And I don't know, but if I put the parentheses here, this code still works. It does the exact same thing. So I think there's optional parentheses. What's up with that? Like if I do this, that's not allowed. So some parentheses are optional. Kind of sketchy, right? And what's going on here is actually Python, which is our favorite programming language, all of us without exception, right? And so Python just assumes that if you don't say anything about your things that are separated by commas, you mean for them to be a tuple. And you can mean for them to be a tuple or a threeple. Doesn't really care, right? There's 1, 2, 3 right there. Count them up. Okay. And I know what you're thinking. You're thinking, why should I believe you that this is a tuple, right? That's crazy. You shouldn't just believe things that people say on YouTube, right? Well, we can check the type, and we can verify that it is class tuple. God, it's so hard. Tuple. So you don't just have to trust me. You can check. By the way, class here, we're learning that not tomorrow, but Wednesday, which is tomorrow to me, right? Because I progress through time in 48-hour increments, right? So finally, we will be able to tell you what you've been looking at all term. Okay, so this is a tuple, and this is the same as if I put some commas here. So that's the tuple. Okay, I often refer to this as the humble tuple because it's not that complicated and it's pretty useful. Probably at this point, you're thinking, how are these different from lists, and why are they so weird about commas? At least that's what I was thinking, right? So let's look at some really unhinged tuples and see how they're all tuples, right? So we can, for example, say, well, let's go ahead and just slap a 1 inside x. So let's just set x equal to 1. That's no problem. We're going to get a 1 back, and we're going to get an integer. What happens if I put a single, solitary, lonely, isolated, all on its lonesome comma at the end of that? Well, suddenly, through miraculous powers, it transforms into a tuple and is encapsulated in those parentheses, from whence we don't not knoweth which hail, as we say, right? I can stop anytime I want. Okay. Can I? I've often said I can stop anytime I want and then continued. Okay, so I know what you're thinking. You're thinking, well, you can just put a 2 there and then this looks reasonable, right? Now it's not extremely strange to look at, but you can also put a comma at the end of the 2. Why? I don't know. I didn't make Python, right? This is a little bit nicer because it means that if you happen to have another tuple down here, you can just like put it directly at the end, which you couldn't do if there wasn't a comma there. This explodes. See, that's not allowed. We got to have our commas. Okay, that's basically all that this slide shows. What can we put inside of tuples? Well, we can put all kinds of things inside tuples. For example, in addition to putting x, 1, 2, 3, 4 in there, which is totally fine, we can also put x in there. We can put print in there. We can put hello world in there. What else should we put in there? We can put the type of 1 in there. You know, you can put whatever you want in tuples. There's not really any rules. And here we have 1, 2, 3, 4 built-in function print hello world class int. That's a completely reasonable thing to put inside your tuple. Okay, I lied. That's unreasonable, but it is possible, right? The reason is you can kind of just put whatever inside a tuple that you want, right? Can we put a tuple inside itself? Not to my knowledge, but I have tried. So, wait, did I show this class that you put the list inside the list, right? You've seen this? I think we should do it again because it's kind of fun, right? Okay, so we got x equals 1, 0. Why not? Then we got y equals x2. And then we just say x equals y. No, x0 equals y. That'll be fun. Yeah, right, like it's the list that contains itself, right? So I don't think you can do that with tuples, right? And why do I think that? Well, let's just go ahead and just knock these little boxy brackets off here. Oh! Oh, what's that? The tuple object does not support item assignment? In a way, that is curiously similar to another thing that we've learned about, which is the humble string. Strings also do not support item assignment. So tuples are just strings for everything. A string is a tuple of letters, perhaps. Is that true? No, not quite, right? Not quite true. Because if we tuple the string, I think we're going to get back h comma I. Oh, sorry, just pretend you didn't see that. Okay, first try, as we always say. Did you see how I got it on the first try?
Yes.
Yeah, we got some liars in here. Thank you. Okay. Sorry, I shouldn't accuse someone of being a liar. That was wrong. I'm sorry.
Why did they add in 2 extra, little quotation mark things?
Oh, because this is a tuple of length 2 that contains 2 individual characters. It's completely different from the string.
Right.
See, but if we were not to tuple it, then it looks as you expect, right? But really, you know, if we were doing this at the terminal, which we all love, right? This preserves the quotes, so those quotes actually are there, and you can see them. You'll love this. By doing this, I think, you can look at the representation rather than the string of the string. See? So those little quotation marks were there waiting to hurt you the entire time. And this is how you can tell one from one. Is everyone having fun yet? I'm having fun. That's not true. I could be having fun. I have chosen not to have fun as a sacrifice to your learning, right? Okay. So who loves, see if I can get this right. What's Eminem's name? Marshall Matthews? Marshall Matthews? Mathers? Who loves the great city of Detroit? Right? We all love the great city of Detroit. That was kind of quiet there, but they got great pizza there. They do the deep dish box pizzas, right? And the Shinola watch brand is from there. So we all love Eminem because Eminem's from Detroit. And so I thought it would be fun to write a function that returns both the minimum and the maximum of a thing, right? And the thing is going to be a collection of other things, right? So let's go ahead and write Eminem. Terminal. Okay, got some no's on the terminal there. That's okay. All right. We will use viz code. Okay. So the first thing I'm going to do is I'm going to create something called x's. Does anyone have any favorite numbers? 11. Great choice. Any other numbers? Okay. I'm going to just throw in some other odd numbers here. We'll maybe even do a couple even numbers just to keep things spicy. Maybe I'll toss in a -7. What do we say? And I can do this. I can take a look at that, but I actually don't have to put those brackets there. I can just leave those off. Oh, and it's a hextuple, which for hex, because there's 6 of them, like a hexagon, right? So it's a hextuple. Some of you may have learned at some point in time that you can calculate the minimum of these things, and the minimum is -7. And you may also be able to calculate the maximum by asking for the max. Sometimes you might want to get both of these things back quickly, and so you might write a little helpful function named after Eminem, which is going to take some collection. I'm going to not refer to it as x's here. I'm going to call it stuff. Because it has to be more than one thing, right? And I'm going to return the minimum of stuff and the maximum of stuff. And then I'm going to go ahead and print the M&M of x's. Okay. And so this is giving me the minimum and the maximum. That's not what I meant to do. Okay? And this is consistent with these slides. But we can check some things out here. So say I want to take the return result of this. I'm going to call this m's, because it's the minimums and the maximums. We can look at m's itself, and we can look at the type of m's. And unsurprisingly, once again, the humble tuple has reared its ugly head and has placed parentheses around our otherwise beautifully comma-separated values, right? So those parentheses, they just show up from nowhere, right? No one can stop them. They're too powerful for us, right? But there's like even cooler things we can do here. And the really cool thing here we can do is we can take lil and big, and then we can print lil, and we can print big. And we can use multiple assignment. So I can take this return statement, which is going to return the minimum and the maximum, minimum, comma, maximum, and I can set it equal to little, comma, big. And the little value, which is the minimum, will be captured and printed, and the big value, which is the maximum, will be captured and stored. This is kind of cool. So we can do this with, I believe you can also do this with lists, which I think we've shown. So this is not impossible, but it is a lot more overhead, right, to have all of those brackets there. So it's somewhat common in Python to pass these things around without having the brackets everywhere, the same way x's doesn't have those brackets on it. And really the only fundamental difference is you're not allowed to change the values. So if I take this back and I get m's, I can print m's 0 and m's 1, which are the same values, right? But I cannot assign m's 1 to be, we'll put in 4012. No, that's 3012. This is 4012. Okay. That is not allowed. So what is the usefulness of this? Don't worry about this too much, but when you return something from a function, you've probably made some calculations about it. Probably you don't want to be editing the results of those calculations. So instead of being allowed to edit those results of those calculations, as we would be if this were a list, we instead say you cannot edit the results of those calculations. So a tuple is a way to freeze the results of some calculations and store the same things that we would be able to store in a list. Okay. So these are basically like lists with different parentheses, and I think what I should do in order to convince you of this is I'm going to turn them back and forth, and I'm going to take a look at some of the things they can do. So here's x's. We're going to rename x's. It's going to be tuples, or tuple x's, and then we're also going to have list x's. There's a few ways to get list x's, and I'm going to print both of these. Oh, posture check. I was slouching. How's everyone's posture? Okay. Oh my gosh. Okay. Got to work on that lumbar spine or whatever. Does anyone know any sports medicine in here? No? Okay. All right. My knee hurts, so if you know why, let me know. Okay. There's a few ways to get a list of x's. Of course, I can just take this and do the old copy paste. Whoa! Whoa, Viz code, no. Okay, so this is one way to get lists and tuples that contain the same thing. You can copy paste. It's a little bit cringe, so we're not going to do that. We're instead going to say, I am going to ask Python to listify something, and I'm specifically going to ask it to listify tuple x's. And this is a way to get a list as well. Now, many of the same things can be done to both tuples and lists. One example is we can in backwardsify them. And so that's the in backwardzification of our tuple and our list. We can take slices of other kinds, of course. So for example, we can look at the elements beginning after the third element and stopping before the fifth element. So that is 0, 1, 2, 3, or perhaps 3 before. And then you stop when you get to the fifth element, which is 0, 1, 2, 3, 4, 5, negative 7. So we stop before negative 7, and we start at 3. So that we get 10 and 12 back from both of those. They behave quite similarly. And then the thing we're not allowed to do is tuple x's 1 equals 14. That's against the law, but list x's 1 equals 14 is allowed. And let's look at all of the list x's to verify that that change was made. Okay, so we are able to alter the values of lists. Now, something I do want to point out, and I don't know if you've thought about this that much, because this was one of the first things I thought about when I was learning Python because of what I was using Python for. But maybe, I think this is like, let's look at the first 3 elements of these lists. So maybe I have 11, 13, 9 in my list. I had always sort of suspected, and then I was surprised when it didn't work, that I ought to be able to assign that slice to perhaps 12, 14, 10. And you can actually do that, again, but only with lists, right? And let's take a look at this. And so this is extremely not allowed with the tuple. Why did I change that? We're going to change this, tuple x's. So that's extremely not allowed. And then the last thing to check is if you can assign a tuple to those locations. And in fact, you can. So tuples can be used to create subsets of lists and then jammed in lists with this sort of slice notation. Should you ever do this ever? Maybe you might do this once or twice on image shop. I'm not expecting you to do this, but it's possible you might want to do this. What happens if this thing's the wrong length? Still fits in, right? And I don't know what happens if you put a 1 here. I guess it just fits everything in. So keep an eye out for that sort of nonsense. Okay. This is the exactly one difference which I've shown you, and I'll show you in code again. Not allowed. Tuple object does not support item assignment. What does that mean? I cannot give an index of the tuple and then say, hey, change the value of that to something else. That is not allowed. That is the only thing that's not allowed. Sometimes this is useful. Sometimes you don't want to be changing things by accident. Okay. Let's look at an unpacking example again. So I'm thinking about course registration. So some of you may be interested in staying in the CS major, which means the next course you should take is CS 152, which is probably called something to the effect of data structures. And it is probably offered in spring of 2026. Is next year 2026? That sounds right. We're all locked in on that. Okay. It's nice to get back on an even numbered year, right? These odd numbered years, they sketch me out, right? I can never tell if I'm more than halfway from the common era or not. Okay, so here's an example of a course. We can create this, and right now it just runs without error. We can go ahead and print it out, and there we have it, right? But we can unpack this whole thing, and I want to show you a time you might want to do this. So I think of this as there being a prefix, a course number, a name, a semester, and a year. And I'm going to set that equal to course. Why am I going to do that? Well, maybe I'm not going to necessarily use those things directly, but now I can print out sort of the shorthand of the course, just like that. And this, I think, is getting to be a little bit cool, right? That's sort of something that might be useful, right? If you have, for example, I don't know, if you have a color, looks like this. And then you say, oh, red, green, blue equals color. Green. Oh, I did my best, okay. Wow, first try. See, I did that on the first try. That was something else that I got that without making any mistakes, ever. Oh yeah, 128, just right out of nowhere. Bam. Cool. So this might be something that is potentially useful to you. Unpacking is pretty cool. So I do this from time to time. When do I usually do this? Sort of the most common time I do this is if I have two values and I need to put them in order. So on div 6.7, that assignment at the beginning where you print out all the things that are divisible by 6 or 7, it took two arguments that were supposed to be a start and stop. But, for example, it could be possible that someone says, yeah, hey, start at 60 and stop at 40. Well, that's a little bit obnoxious, right? But we can actually solve this problem pretty easily with multiple assignment. So let's go ahead and print out start, stop. And why does this not work great? Well, because the list of values in the range from start to stop, there's just like nothing in there, right? But what we can do with sort of multiple assignment is we can say, well, start, stop is going to equal the minimum of start, stop, comma, the maximum of start, stop. And this will put things in order. And will this code work? Sort of. Seems to not be erroring. So let's go ahead and take a look at this. And there you have it. We're able to just sort of put things in order. And this code works no matter what. If these things were already in order, if we had 11 and 13, that's just going to work the same way. So you can sort of force pairs to be in order, which is a really nice thing. This I do all the time. Usually with shorter variable names, so that you can see this is much nicer if you do start to x, stop to y. Did that not change? That doesn't look bad at all. You can do one other one here if you're not specifically in the minimum maximum case. How do we do it? Sorted xy? Is that right? Actually, can I just put xy in here? That didn't work? Okay. This also works. So I can also, if I have a list of length 2, this is crazy, right? You understand that this should never be allowed. This is wrong, right? But it's like kind of cool, so I'm showing it to you, right? We can take a list of length 2, we can sort it, and we can unpack the list into minimum and maximum. That's why is that allowed, right? This could make us too powerful. You're all looking at this like there's no way any human could ever possibly understand it. Is that the vibes? No, you're locked in? All right, fair enough. If one of you's locked in, I assume, so all of the faculty, we have to share one brain, right? I think probably all of the students have to share one brain, right? You just like take turns using it. And so like if you're working on a Rubik's Cube and it's not your turn anymore, you're like, uh-oh. And you just have to like hold the Rubik's Cube for a while until it's your turn to use the brain again, right? So I do all of my thinking at night while no one else is using the faculty brain, right? That's why I'm like this in class. Okay, so multiple assignment, very cool. Very, very cool. Look, it's the exact example I showed you. Sometimes I almost think that I made these slides just for me. Okay, I will say one thing. Pretty much every interview question I've ever seen has a place in it where you can use this like multiple assignment to swap values, and not every language allows you to do this. So this is kind of like a Python thing. You can just do this in Python, which is crazy, right? We'll do 15. So, when would I ever want to do this? Well, You can also do, okay, stick with me here. You can also do this inside a list. Okay, so imagine I got x's and it equals, I'm going to do 5, 3, 7, 2, 4, 6, 8. Okay, print x's. Okay, then what I can say is x's 0, x's 1 equals min x's 0, x's 1, max x's 0, x's 1. What is all that nonsense doing? Let's see. I used the wrong brackets. What am I going to say when this works? First try? Yeah. No, we're saying first try. Why would we not say first try? We got it on the first try. It's the 0th try we didn't get it on, right? So what is this like crazy nonsense doing? It's like, well, this is allowing me to put a list in order. And change this to I. Actually, I wouldn't even have to do that, right? We can say I plus 0, I plus 1, I plus 0, I plus 1, I plus 0.
Is I plus 0 not just always I?
Yeah, it's always I. Is this going to work? Okay, this one? Am I missing anything else? The colon? Am I missing anything else? I have an off by 1 error. I plus 1 goes off the end of the list. And this doesn't quite sort the list, but it's more sorted. Well,
Sure.
hear me out. What happens if I do it again? Ooh, we're getting closer. And so that you can sort lists doing this if you're like really into that. We know how to have a good time here in CS 151, right? Like, when was the last time you put those numbers in order? I don't know that I've ever done it starting at 2 before, right? I always start at 1 when I'm putting my numbers in order, right? So we really know how to have a blast in this class, right? Okay. Here's the example I just showed you. This is vowels between, where you can give things in any order, and then you can get a range back. Pretty cool. When I first read the instructions for divisible by 6 or 7, because I didn't write that, I assumed we were going to check to see if you checked this, and then we were going to be mean about it. That's not true. No one checked. But this broke all of your code. And technically, I think I was allowed to check it for that. But I'm nice and cool and chill, so I wasn't mean about that. I was probably mean about something else. I don't even know if I'm mean or not anymore. It's been like so long since I've gotten like a sense for that. So do let me know in those course evals at the end of the term if I'm mean or not, right? Then I'll correspondingly be nicer or meaner next year. Okay, so some of you have found enumerate already. I don't know if that's true this term. I don't think I've seen it. I think maybe I saw it once, and I can't remember if it was this year or last year. But enumerate is pretty cool, and it's like vaguely tuple based. So let's just take a look at an enumerate, and we'll go from there. I'm going to just take some letters. Is this going to work? Print x's. Okay. There you go. Okay. So I got some letters, right? I took 6 of my 26 favorite letters, but I selected them arbitrarily. These could have been any letters, right? And what I'm going to do with these letters is I'm going to enumerate over them. And what's that going to do? Well, by default, it just returns an enumerate object, which is maybe the most annoying thing that has ever been returned by a function other. So how can we look at this? Well, there's a few ways we can look at this, but the most obvious one is for x in enumerate x's, print x. Oh, and what's that? What's that? Are those both tuples and tuples? I think they are. I heard the sound of you not believing me. Oh my gosh, they're tuples. It's tuples. It was tuples the whole time. Why do I care about this? I mean, you're under no obligation to care about this. But, well, we can do a few things here. We can get the index and the value back from x. Then we can print, I don't know, what is that? Like, x's plus, wait, those are backticks? That's the wrong quotes. I don't know how to use quotes. Okay. X's plus index plus close this equals value. Is that going to work? I can only concatenate strings to strings. Okay, so I have to turn this into a string. That's okay. I think I know how to do that. Parenthesis was never closed. Okay, there we go. So I can unpack that tuple, and I can say, hey, the value at this index is equal, or yes, the value at the index is such and such, okay? This, I think, might have been, like, kind of useful in Wordle, maybe, but it's definitely been useful in some other things. So sometimes you want to know both the index and the value of something, and that's fine. I think this will, let's see. When would this have come in handy? Oh, like I before E except after C would have been pretty useful with this, right? You just check the value to see if it is C or I or E, and then you check. You can check by index. I'm going to get a little crazy here, so hold on to your propeller beanies before they fly away, okay? This line is totally unnecessary because I'm just taking x and then I'm looking at x right here, so I can actually just take this. Okay, hang with me here. I can do, I'm sorry, I can do multiple assignment inside a for loop, okay? Look, I didn't want to do it either, right? But that still works just as well. Also, you don't have to look up the value like this. You can look at x's index and it will be the same every time. So that's mad goofy. But when might this come in common? So here's like the example with histogram. So let's just take hist real quick. Let's see, x's is not defined, no problem. We can do hist. Okay. And then we will do stir value. Okay. So this is getting pretty close to the histogram assignment, right? But we can do something else here, right? We can take the index and we can show how much stuff there is at a value. So let's get rid of x's. I think this is now a colon. And that's just going to show me how many of things there are. But then I can also take the value and multiply it times asterisk. And that is one satisfying way to do the histogram assignment. Now, okay. Does this code look horrific? Yes. Specifically, multiplying using the multiply operator times that character inside of, that's wild. But we can maybe make this a little easier by just doing dashes. Maybe that's not as bad. Maybe do underscores. That looks fine. There's a few other ways we can make this not as awful. I don't know that we particularly want to dwell on any of them, but it is in fact possible. So this is slightly wrong, but not the wrongest thing you've ever seen. So this introduces an unintended space, but then we are comma separating things. And actually, you can just check the type of this. Oh, we can't. I expected this to be a tuple, which I think it is if we do this. Oh, I'm not printing the type. Hold on. Print type. So really this whole time we've just been furnishing tuples to print. And it's been formatting them slightly differently. So tuples, the tuples have been all around us the whole time. Isn't this wonderful? And I think the last thing we need to try is if x's equals 1, 2, def add xy. We're just going to print, we'll call it show. I don't know. Print x plus y. So in theory, if I show 1, 2, that's allowed. It's going to come up as 3. Can I also show x's? No. So there is one time you can't use these, which is even though we give comma separated, I don't know, series of values to functions, you can't just pass a tuple directly. You would have to unpack it, and you would have to do all of this obnoxious stuff. 0, 1. And then it works. Under absolutely no circumstances should you use an asterisk in front of a tuple to unpack it into a series of things. Don't do that. It's not allowed. I'm showing it to you because it took me 6 years to find it. No one would tell me about it. So if you ever get stuck, just start putting asterisks in things, okay? Or don't. Okay. All right. That's probably is today the most scary lecture so far? It feels scary to me. Okay. I think basically you're not supposed to do any of the things I'm showing you, but you can. Zipping is awesome. You're probably going... You don't have to use zip. Your life might be easier if you use zip, and it certainly would be more easy. Green screen is easy if you're familiar with zip. That's my claim. If you're not familiar with zip, you can synthesize it. So let's look at the motivated Wordle example. We got a guess, which is going to be hello, and we've got a an answer, which is going to be world. Why not? Okay. So we can obviously print guess and answer. Not too bad, right? Easy. What happens if we zip them? Oh, we get a zip object. Great. Something I can't actually see. Okay, so what are we going to do? We're going to do what we always do. We're going to say for x. I'm just saying x because I don't know what it is. For x and zip, print x. It's a bunch of... It's tuples again. You see this? Can you believe this? These ones are tuples, but it doesn't have to be. Aegis. They can be threeples, too. Right? No one can stop you from threepling if you want. I suspect you're only going to want a tuple. Okay. So, what is this? Okay, well, that actually means that we can take the two letters, print them separately, so we can unpack the zip. But we can do a few other things. We can just check to see if they're equal. And this is a way you can check to see what letter or what color letters are supposed to be on Wordle, right? You just zip them up and you check for equality. When is this useful? Well, what you can zip together is you can zip together the green screen image and the foreground image. I don't know how to spell foreground. And then what do? You if green of green screen, blah, blah, blah. And then you show one thing based on the value of the zip. So that's what I'm doing here. Of course, you don't have to do this with a zip. Let's go back. So this is the zip version. We don't have to do it this way. I'm going to say for I in range, length, guess. And then I'm going to say guess I equals answer I. This gives the same result, but this only works if they're the same length. Otherwise, you get in big trouble. What happened? Okay. Otherwise, you get in big trouble, right? I'm successfully able to check the first 5, and then I get a trace back. So, if I instead zip this, I get the much nicer things zipped up appropriately. Okay. I'm flagging this text for you. This is my recommended way to push through milestone 3 if you get stuck. You're probably going to have rows of pixels, one from the foreground and one from the background. You're going to check to see if something is true in a zip. And then you're either going to add one pixel or another to maybe the row of pixels you're building up. And that's what I recommend doing. Okay. We have some bonus slides. These bonus slides are essentially philosophical remarks on a term that existed in computer science that I have never heard outside of talking to people that taught this class 20 years ago. But I'm going to tell you about it because it exists in the textbook that you all knew about and were reading, and it might come up in like a section or something, right? That same word that appears twice in the first line is in quotes for a reason. It's because it has different inflection. We can record things on a record board, right? So the different inflection. We can verb record things on a noun record. A record is an abstract idea. It is not a programming language concept. There is nothing I can type into Python that when I check the type of it, it will say that was a record. A record is a problem I'm trying to solve, and there are different technologies that can solve the problem. I can use a tuple, or I can use a list, or I can use a mysterious third thing as a way to store records. Usually, when I deal with a record, I don't think or care about whether it's a list or a tuple. Let me prove this to you. I'll just take all of this and then I'll edit it over. So I have this code. This code was meant to be run in the terminal. That's okay. Terminals are silly geese. I can run this code like, let's see, I think I have to trash can. There we go, CS151. If I put this in brackets, if I use a list or a tuple, the code is unaltered. It runs exactly the same way. The same thing is true if I put brackets here or not. The same thing is true if I change these brackets back to parentheses. There are design decisions I can make while writing my code where I decide to use a list or a tuple. If I don't use anything inherently listy or tupley about it, it makes no difference which one I used. One example of that is just storing some data, like the name of a class. If I just need a record of something, I can create a record using a list, I can create a record using a tuple, or I can create a record using a mysterious third thing. So there's this concept that sort of exists a little bit like, I think of it as higher, but like it doesn't make sense to think of it in a direction, but not inside a programming language, but inside our minds as we're using the programming language, which sometimes, I need a way to store these 3 colors. It can be a list or a tuple. It does not matter. I need a way to store this file name and what folder it's in. It can be a list or a tuple. It doesn't matter. So there's these things out there that we want to use the idea of a record to store. So you can think of this in terms of the advising system, which is how I think of it. But I do not know. I think if I just type CS in here, I can get it up. I got an email that says I was going to lose access to this yesterday, but I didn't. So perhaps you want to take this course next term. I do. Why is that so slow? Okay, so they used the wrong type of record, but that's okay. We got it on the first try. I do not know what programming language this website is written in. I know I'm looking at HTML and JavaScript, but that doesn't affect me, right? I don't know if that 152 is stored as a number or a string. It doesn't really matter because we never check to see if two classes have a higher or lower number, so it doesn't affect anything. But I do know that somewhere in a computer there is a record that stores all of the information on this screen, right? So probably somehow every year has to be stored. I'm guessing that's stored as a Boolean that says every year or not every year, but I don't know. Maybe it's stored as the string every year. I don't know. I just know there is some record somewhere holding this information, but it doesn't matter whether it's a string or a list or a tuple or Python or anything else. So this is an example of where records exist in real life. Same thing is true with math. So any of you super into the CS major, leaning that way? I would recommend taking Math 251. Math 251 is one of the only classes that you can take right after CS 151 that not everyone takes right after CS 151. But if you take it in spring, you get to take this class in fall. CS 351 is a fall-only class. It is one of the classes that most commonly causes people to be stressed out about when they're going to graduate. You can take it your second year if you take data structures, which is CS 152, the next class in this Python sequence, and Math 251W, Foundations of Advanced Math, which teaches you a little bit about things like set theory and induction. And set theory and induction are what tuples and lists are made out of, basically. The for loop is induction, the set theory is the collection element, right? So once you take Math 251, you can take this class in fall, and then you have a much less stressful remainder of your time here. Now, many students find Math 251 to be a different type of challenging, not necessarily more or less challenging. So if you're stressed out about next semester, just delay it, don't worry about it. But if you're eager to get going, think about taking Math 251 next term. There are math majors in here. Can anyone tell me a little bit more about Math 251? They're usually on this side of the room. Are they?
They're all gone.
They're all gone? What do you think about Math 251?
I really liked it, but obviously I'm
Yeah,
biased.
yeah.
For anybody wanting to take it, it's not like calculus where you like calculate derivatives or like you have, what's the, like this where you're kind of, it introduces you to proofs, and so that format is like, show that if you square an even number, it's still an even number, and stuff like that. So, logic and such.
Okay, thank you. Looks like there's 2 sections, so think about it. And they're both taught by Professor Johnson, which is very exciting. Everyone loves Professor Johnson. So, okay, so that's an example of a record. So a record is an idea. It is not a thing. I'm going to use the term an abstraction. We can pretend things are other things, and that's what an abstraction means. We implement the idea of a record with either a tuple or a list. And then on Wednesday, we will do the third thing. Okay, closing thoughts. I think we're out of time, right? Try and get through milestones 0, 1, and 2 soon. Get to the annoying stuff quickly. Take care of milestone 3 on Wednesday and bring questions to class if you need them. And then get started on milestone 4 to ask questions on Friday and Monday.